Generally, if you want to get the best performance ones, use OpenAI functions. As Elad was saying, keep it kind of like really focused and narrow. The biggest blocker that we see when people are building agents today is just hard to get them to a level of reliability where they actually work. You can't kind of just give them functions and expect them to work off the shelf. There's a lot of, you can do that and you can get a Twitter demo, but then getting it to work reliably is a lot more work. And specifically the type of work that we see being done is really clever and advanced and detail-oriented, like prompt engineering, communicating really clearly, and this includes function descriptions as well, communicating like really clearly what it should be doing, and then also really clear and precise kind of function selection. So if you want an executive assistant that can manage your calendar, you need to give it access to read the calendar. And maybe like the generic, I was actually working on this the other week, and the Google Calendar API is very broad, so maybe you want to give it, like, when we go to the calendar, we click on like the day view, and then the month view, and the week view. So maybe that's a slightly easier way for an agent to think about interacting with the calendar. And so I would basically encourage people to really carefully think about what they're telling the agents to do, and really carefully think about what functions they're giving the agents to do. And it's very, very likely that the default prompts that you see in LangChain or anywhere, and the default functions that you have in LangChain or anywhere else won't be enough to kind of like get the job done, and you'll have to customize them, and you'll have to give them custom functions. We've been hearing this for a while. We've been working on kind of like tools to help people do this better. One of the things that we recently launched this week is Langsmith, which basically, I can't really describe it well, but we call it kind of like a debugging, testing, evaluation, logging framework for LangChain and in general LLM applications. So we'll give everyone here early access, and we can send around the code in the Slack channel afterwards. But just to give kind of like a very quick overview of what it is and why we think it's useful. It basically logs everything in the background. You can kind of see all the different chains and agents executions that are happening. And then importantly, this gets into the debugging mode, which is where we mostly use it. Let me just go full screen. You can click into runs and see kind of like what exactly is happening. So you can see here that we have an agent executor. This is actually not a project that's even in LangChain. This is an open source project built on top of LangChain. And you can see here that they're giving it some tools. You've got the calls. You can click into a chain. You can see that this is the LLM chain. This is just prompt plus language model. You can keep on clicking down, and now you can see exactly what's going into the language model and exactly what's coming out. So a lot of errors and bugs that we see, there's basically two big things that go into building language model applications. There's like the prompts, and then there's all the data processing. So when you're passing it documents, what does that actually look like when it's going into the language model? When you're splitting text, how big are the chunks that you're splitting it into? And so seeing exactly what's going into the language model and exactly what's coming out of it can be a really good way to sanity check that you're doing it properly. You can also then hop into a playground and mess around with it here, so you don't have to kind of like copy paste. This is really, really useful for debugging something that happened like halfway down like the agent execution trace. If you get to a point where it's done one or two steps and then it makes an error, how do you kind of like isolate where it is at that specific point? And so kind of like this level of debugging will allow for that. So yeah, we'll give people access to this. Would love feedback. I'll be hanging around kind of like all afternoon and evening. Would love feedback, and also happy to help kind of like get up and running with it. Really excited to see what people build. I think like, but the only other thing I'd say, like I think like I think the project that won last time was an agent eval thing, right? Yeah. I would love to see an actual agent win this one, and not a project for evaluating agents. That would be my only try. But I'm sure it'll be a fun afternoon, and yeah, see you guys around. Thanks for having me.
Okay, coming next, we're going to have Simon School, CTO and co-founder of Llama Index, telling us on how to build agents with Llama Index. So, another reminder to build agents today. There you go.
Hey everyone. Alright, let's wait a couple of seconds for the slides to load first.
Okay, as that's going, let me introduce myself a little bit. Simon, co-founder, CTO of Llama Index. I've been working with Jerry on this for quite a while now. Before this, I was actually building human driving agents for self-driving car companies, basically learning how humans behave in the real world to test and train self-driving vehicles. So very excited to talk a little bit about data agent. This is something that tools. As Eli has talked about, this empowered knowledge worker is really the future, but we gotta focus on building the very specialized use cases. So for example, an executive assistant needs to read the latest emails, correctly retrieve the relevant context, whether that's within Notion or Slack, and maybe pass that off to sort of a sub-agent for analysis, and then finally send an update to Slack. So building this broad agents probably, you gotta build the most special things to deliver value, and Llama Index is the toolkit or data framework to help you do that. Very quickly, I think people already are familiar with the core components. We just added sort of our native implementation of agent reasoning loop, whether that's the OpenAI function calling agents or the React agent that work with all the LLMs. And we actually recently launched the Llama Hub, various different toolkits, co-contributor, Slack, Notion, Zapier, where you have 15 plus tools and 100 loaders. So very easy to get started to build out your specialized agents. Now, here's a couple lines of code that you can build an agent. I think we're all familiar with this, so I'll just pass that. I think what I want to spend the most time talking about sort of are these advanced considerations in building data-specific agents. One is to basically the challenge of operating over different data sources and really index and retrieve different kind of data, whether that's unstructured or semi-structured or structured. And second of all, like how do you build hierarchical agents and sort of pass off the specialized task to a sub-level agent that the top-level agent can orchestrate. And lastly, some of the utility tools that we can that we have in Llama Index to help you handle large API responses. How do you retrieve the right tools over a large number of APIs? And how do you really have these practical tooltips to design the robust tools that anything can use? First of all, how do you retrieve and analyze data from different knowledge bases? This is something that Llama Index does specifically well. We have a toolkit, many different types of query agents that can act as data tools over the agent framework that you're building. And this could include summarization, search, text to SQL, document comparisons, and combining structured data with unstructured data. And the benefit of this is that it provides a very simple interface so that your agent can make less mistakes, and all it has to do is infer a query string over the various knowledge bases that you have. So how do you handle a large number of tools? This is a question that we get from various users and customers. The approaches that we have here is build an index over your tools with some Llama Index constructs and retrieve the most relevant ones to pass to your agent. And this will help be more robust to kind of call a different number of underlying APIs. And how to handle large responses on tools. This is a common challenge that people have been asking about, whether if you're kind of querying a Wikipedia article or getting a very large data from various endpoints. We provide a tool to kind of load that data and kind of load it into an ephemeral index and build a query agent on top so that your agent can very easily utilize these large responses from APIs. And sort of very lastly, I want to spend the most time here, how to build better tools. In the process of building out sort of the toolkits for data agents, this is the area that we thought the most about. First of all, writing the tool prompts in a very clear and concise way is one of the most important things that you can do to make your agent perform well. Really think about having the right documentation for anyone to understand exactly how to call your API. And second of all, making the tools tolerant of partial inputs is something that generally helps the robustness of the tool quite a lot. Very often we find when you build a tool over, for example, Gmail, you might want to create a draft. When the agent capability is not the best, they will often omit, for example, send to someone or subject. And when you can infer the right sort of parameters from previous requests, it makes the tool a lot more robust. And some of the other considerations are validating the input in the function so that you can reduce the burden on the agent, and kind of returning the right error messages that guides the agents to make the right decision. For example, when something is missing, just clearly describe what our parameters are missing. And yeah, we're really providing simple functions that constrain the sort of interface for the agent, makes the function calling a lot easier. And we have the full guide that we link here, which we'll send out to for people to take a closer look. Yeah, yeah, and maybe lastly, some ideas to explore that we've been kind of thinking about. How do you do automatic tool creation from client APIs in the wild? So with various, a lot of times, like within an organization, you have a lot of internal APIs in the hundreds or thousands, and manually constructing these tools, as I described in the previous slide, is very difficult. And how can you automatically leverage LLMs to create these tools from sort of undocumented APIs is a big challenge. And number two, this idea of context engine for agent applications. Very often we find that in an application, the most magical experience is when you have the most relevant context surfaced given sort of whatever state that you have in the application. If you're in an email application, really eagerly retrieving information about the sender and sort of the topic that's being discussed in your email will really create these magical experiences. In terms of the last 2 points, this idea of invisible agents is when you want to build the most magical experience, the agent should kind of like fade out of the view, basically really sort of surfacing the information that's relevant only when it's necessary. And yeah, I think I'll conclude that talk.
All right, up next, Raul Jati from AWS, SageMaker, Chief Engineer.
Hey, I'm gonna bring the mood down here. Is that okay?
I wasn't expecting that from you.
All right.
All yours.
Thank you. You ready? Hi, I'm Andrea. I'm the chief engineer for SageMaker at AWS. SageMaker is a platform that allows companies and enterprise to deploy AI at scale. We have some of our biggest customers in the world, and if somebody does AI, most of the folks that we deal with are either individuals like you or large enterprises. But I'm going to talk about what is going to happen in 6 months. Right now we're doing demos and we're all trying to build cool products, and that's awesome. Happy to talk with you later on. But what happens when you have to put these systems in production? What are you going to do? Like, you're going to keep using the largest, best models that are also the most expensive? I don't know, right? I don't know where that story is going to end. What I do believe is that choice is key. You want to be able to take whatever model works for you, whatever system works for you, and make it work at that point in time, and potentially have the ability to swap out other things. And I want to encourage you all to think about how do you build all these agents in ways that allow you to swap in, swap out, use different methods. How do you make systems, how do you build systems that will be not only cool to use, but also affordable to deploy in your enterprise? We have a bunch of choices to run. We have Amazon Bedrock, which I just talked about, but also we've seen our customers try out a whole bunch of new models. We have Llama 2, we have Falcon, we have Stable Diffusion, Excel, and a whole bunch of other systems. How do you choose? How do you go back and forth between all these systems? That's something that I would love to see maybe one of you folks work on. We also have partnerships with Hugging Face, and you can deploy to SageMaker. We have day one support on LangChain with Harrison. We talk. There you go. Everything that you can support on LangChain, and you can swap things in and out. But the thing that I really I would love for you folks to focus on is kind of this one here, right? How do you measure quality? How do you know that the quality of the agents that you're going to build is constant over time? Are we good?
Oh, you're good.
How do you know that your models are they don't suffer from toxicity, they don't generate output that you don't want? How do you build all these things? That's an area that I think is still underexplored. Because again, we're not in that phase again. But if you look ahead 6 months, a year, you're gonna want to think about that. And there's a whole bunch of cool, interesting projects. Some of them are research, some of them are deployment into production that you can think about. And plug here, we have a whole bunch of tools to help you kind of understand, train models, fine-tune them, but also deploy them, monitoring them in production. Right? How do you monitor an agent in production? How do you know that the answer that the agent gave you still makes sense? You made sense 10 days ago, but what about now? How do I know this? Like, I would love some of you folks to think about that. And integration with human annotation is going to be super important. As you build the systems, as you interact with humans, you're going to want to take some of those learnings and bring them back. How do you make all this seamless? I don't know that we have all the story in place. We have integrations with ground truth, and we have UIs, and blah, blah, blah. But I'll be around for the next hour or so, until 1:30. I cannot stay any longer. Shoot me an email if you want to connect, if you just want to talk. I'm happy to engage with you. All right, folks? Hey, have a great day. Enjoy. I want to see the coolest stuff, the coolest agents ever come out of this hackathon. All right, thank you.
Okay, up next we have Francesca Cianella from India talking about Nemo guardrails, which is going to be addressing one aspect that.
Yeah, how timely.
Perfect. Plus, we have two Italians here on stage. I swear I didn't do it on purpose. Okay?
Yeah.
All right. Let me do the
Are there folks in the back who can't see? Raise your hand if you can't see. There's room for like at least a half a dozen people, if, like up here if everyone sort of on the floor if anyone wants to try to sneak in a little bit.
So hello everybody, my name is Francesco and I work as product manager in India. And thanks for having me, it's good to be connected with this presentation. So the team I work with is developing other products like Triton, inferencing server, Fast transformer, Real, that kind of thing. Probably more popular in the community. This Nemo guardrails is quite new and we launched it on end of April. And you have to think of Nemo guardrails more as an end-to-end framework to build chatbots. It's not something transactional where you ask something and you get two results or something like that. It's more of a framework end-to-end. And we have identified in the security domain 3 types of rails. So what happens is that since you have this framework, end-to-end framework, you can tap into every, let's say, extension point of the conversational AI pipeline. So whenever something comes from the user, you can apply a rail. Whereas before something goes to the LLM or after something comes back from the LLM, you can apply a rail. So that's the idea, it's an end-to-end framework. So there are 3 categories of rails. We have the topical rails. Those are, I would say, more simple. They are related to whatever comes back from whatever the user is producing. And if you squint, this is just intent detections, just an LU on the utterance coming from the user. So you can make sure that the user is not going off topic and stuff like that. This, I think, on this category, the tool is pretty strong because it's intent detection basically. It's been around for a while. The second category is the more interesting one for the community. It's about fact-checking, hallucination, stuff that Andrea was talking about before. And this is where I'm shifting the focus of the team, the engineering team at the moment, because this is what people are asking, the customers we talk with, like they say, yes, retrieval augmented generation works, but still, if it's a bank, an enterprise, we still need to have a fact-checking after the LLM has generated the answer. So fact-checking is our main focus at the moment. And hallucination is, again, open research problem. We're doing our best. But so the focus is going to be there. And we're working with lighthouse accounts, like banks and financial institutions to build this type of rails and then we'll share with the community. At the moment, we're not so strong at this. It's like we use fact checking using like self-check paper, that kind of thing, like prompt-based. We go back to the LLM. It's pretty simplistic. But yeah, we're building strong safer rails. That's our mission. And and then share with the community. Finally, security, it's like, this is again, nothing, no rocket science is about. Since it's an end-to-end system, we offer an action server where you can execute your code. If the LLM is producing code for you, you can execute it safely on this safe execution environment. We do type checking on returns from API to make sure that they comply with signature. Finally, this is where it sits. It's an end-to-end system. There's the user, there's no guardrails. You can have something in the middle like LangChain or Raman index. But you would use this not as an agent in this case. You would use those toolkits more as a retrieval system, retrieval adapter to connect to the retrieval system. You can use it as an agent, meaning you can use LangChain as an agent, and maybe you will be interested in doing this later. But then it becomes a little bit cumbersome to use NEMO guardrails inside that. In that case, you can just go ahead and pick the script from the repository. So there are Rails script, Python scripts. You can just apply them in chains. So it becomes much easier to use them. So this is all I had. It's open source on GitHub. Feel free to fork it, open issues, and you can connect with me on LinkedIn. And there's the NEMO guardrails email. We hope to be engaged with the community on this effort.
All right, up next we have Cody from Pinecone, one of the most famous vector databases.
No presentation, just me. Everybody, my name is Corey. I run customer success at Pinecone. I did not get pulled over by the cops because I'm on my Harley today and they couldn't catch me. So I think everybody in the room should know who and what Pinecone is by now, right? The reason I'm here is, first off, to help anybody get started. If you don't already have a Pinecone account, come find me. We'll get you set up. I'll walk you through it. The other is there's been a lot of talk about context windows and large context windows rendering vector databases obsolete. Very much not true. There's been two studies recently. One, a paper out of Stanford. One was a study that our own researchers did that corroborated their results, which is that as the context windows grow, the agent's only going to look at the first part and the very end part. Right? So if you have 100,000 tokens, it's only going to consume the first 2,000, 3,000, and then the last 2,000 or 3,000. Everything in the middle is just discarded. So that's where vector database comes in. We can store all of that individually, and the agent can go back, reference it, get the proper context, and actually perform the way you expect it to perform. So that's really all I have to say. I'll keep it short and sweet. And again, if you need help at all with using Pinecone today, I'll be here until at least 5 or 6.
You helped us fill up to the timeline, so I really appreciate that.
Well, some of these guys were going a little long, so it's like, you know what, I'm going to do everybody a favor.
So
Get back on track.
So we have Shayak from Camaro right now, and while you're plugging, the paper you were mentioning is called Lost in the Middle.
Yes,
if you're curious, you can just go and you will find it everywhere on Twitter.
Yeah.
There you go. Stage is
Thank
yours.
you. Can you hear me?
Yep.
Right. So as soon as this shows up, we're going to talk a bit about evaluating agents.
Okay.
This is think bad guys. It is.
Just gotta talk now.
Okay, so you just have to use a few seconds.
Alright, sweet. Cool. Yeah. So we're going to talk about evaluating agents. And so, how do we really test agents right now? So, step one is we build an agent. Step two, we hope and pray that it does not destroy the world. So, easy two-step process. Except we're trying to do slightly better than that. So you can check out our GitHub project. So Primera, taking a step back, is a full lifecycle AI observability platform which you can use to test, debug, and monitor your AI. And what Truance does is it's this experiment tracking system to help track what's going on with your apps and you can use it with LangChain and Llama Index, and if you're building your custom apps. And as you do that with one line of code, you can connect it to them. So you can start logging all the inputs and outputs, and then as you iterate on your prompts, your models, your parameters, all the good advice that Simon and Harrison just had on how to build better agents, you can make sure that all of that is tracked and debuggable. So one of the key components of doing this when you're working with LangChain or Llama Index app is to do slightly better than Hope and Prayers and use these things called feedback functions. So what feedback functions let you do is to specify what good looks like for your app. And we have a number of them out of the box, and then you can also define your own custom ones to really be able to specify this is what I need my app to do, and so that you can really get that test-driven development loop going. So examples of feedback functions that we have are things like custom feedback that you can write. You can write an agreement with ground truth answers that you might have, and then it's very easy to implement and add to your system with one line of code. So to show an example of experimenting with agents, we wrote this simple app with Yelp using Llama Index and the Llama Hub toolkit they just launched recently. Essentially, what we find with this is that if I just compare that to a simple OpenAI app, it just does much better in terms of having more specific answers, and does a lot better in terms of giving answers which are most close to what you need to be in terms of ground truth. So you can do that. You can use this QR code to look at this notebook that walks through how to hook up this kind of a Llama Index app with TrueLens. And I'll just walk through it very quickly in terms of what that looks like once you do that. This is kind of just a few lines of code to make sure that's hooked up. And then as you test it, all of that gets logged, and you can just compare how well it's doing against some simple baseline. So in this case, I just see it's doing much better than what a very simple chat app would have done. And then if I want, I can just also deep dive into what's going on, look into examples which are not doing as good, look at the prompts, look at why the results were the way they are. And that just lets you build your app in a much more systematic and scientific way, if you will. Right, so just returning to the example itself, you can try to use it for your Hackathon agents. Here's a fun squid QR code for you to go look at. And then if you'd like to meet us live, we are doing an event next week with Simon and Jerry at the Midway next week. So if you'd like to learn more about testing and evaluating your app, come see us there. All right, thank you so much.
All right, another very familiar phase of the AGI house. Deep. Come tell us about how to build autonomous apps with the Hackathon API.
Thank you, Solomon, for the practice. Okay, so I won't be doing that as given the state of the internet last time.
Fool me once, not twice.
Yeah, okay. Cool. So, yeah, so very excited to be here. And what we're doing is we essentially have a Multion API, and we basically just got it into LangChain just this morning, so thanks Jason for that. And so you can just use Multion through our API from like LangChain or from our Python SDK. We also have a JavaScript SDK if you want to use it through that. And the way to think about this is essentially like it's like a new browser. So if you want to do anything on the browser, you can just basically hit an API that will automate any sort of web interaction, do that for you and send you back, along with a screenshot of what's happening, and then you can customize it, give it instructions. It can show you as it's signing out, like how the workflow works, and then it gives some examples. So this is how like Multion works if you are using it like manually. And in this case, you can use it to say book a film and meters. And so that's triggered. We do one other thing. And the nice thing is you can make this into an automation where you can use it from like your Jupyter notebook or even from mobile app. And so using the mobile Multion API, you can embed it into like WhatsApp, into your phone app, or like Slack, or whatever you want. So I can show an example of like a mobile app. So this was actually built in an Agile House Hackathon, during obviously our first prototype of the API. And here you can have like SMS AI to order your dinner in a sense. And then you can see we can do everything. So currently this is running on your laptop. You'll also have this running headless, so you can just like use it from anywhere. Okay, DoorDash is not on headless, but yeah. And so yeah, so the goal for the hackathon is like to build autonomous apps, and you want to be able to build like very like autonomous apps that can do like a lot of different things on the internet. And so you can just like connect to our API and be able to like do any sort of like internet interaction. I'll show you a final autonomous app we built, which can actually where we can actually use AWS. So let's see. Okay. So this is, we connected ChatGPT with our Multion API, and here we had it like modify its own AWS backend. For example, and so you can give like different commands and step by step over the API, and so you can have an outer planner agent or whatever you want that's interacting and using like Multion as a sub agent to do like different things, give it different commands, and execute the code. Here it can go and then redeploy it on the backend. Cool. And yeah, so if you want to use Multion over the API, you can come to us. We like you can also download Multion like from the Chrome Web Store as a one-click install. Unfortunately, the Google folks went on a holiday yesterday, so you're not able to get all the latest patches in. So if you want like the latest API, you can basically come to us and we can help you locally install the extension. Thank you. And finally, we are also hiring. So if you want to come work with us, thank you.
Alright, Sonal from Meta/Fear, talking about the future of autonomous maps.
Hi, my name is Sonal. This is going to be a very different talk. There are no APIs in there, no code, nothing. It has few slides, but I want to talk about, from my prior experience of working on systems and LLM and NLP, what do I think is the future of autonomous apps? And I want to make sure here's my vision of future of autonomous apps. So hopefully this is the one it is, but like we'll see how the future lands. Also, this is not the view of my employer or any of the previous employers. A little about me, just so that you can contextualize what's to come next. My background is an NLP researcher. I have a PhD from Stanford. I've done lots of language understanding, question answering, fine tuning. Human in the loop before human in the loop was cool as an alignment. Primarily worked on assistants. So I worked at Viv after graduating from Stanford. Viv was founded by CD founders. So it was like CD 2.0. And we were building a platform for assistants. And the idea was that all these apps are getting created. Alexa skills is getting created. People want to have an assistant, all different kinds of assistant. How do we bring them together into a platform? I'm sorry. So that was Viv, and then after that I joined Facebook Assistant. I built a lot of first-party apps in Facebook Assistant, technology behind it, shipped it on different devices. More recently, I've been doing more multimodal Gen AI, so make a video was the work out of my team. So video generation from text and so on, back in the LLM NLP world now. So I just want to talk about like what's wrong with current assistant products. So we have like Alexa, Google Assistant, and a zillion other things that happened and then died. And they used to have limited language capabilities. They do many things for the users, not as many things as we would like them to do, but they know little stuff. They don't know too much, apart from going to search and getting results. It used to be a really manual task, so you will have intents and slots, and a lot of annotated data. So this is what I did a lot of time, is sitting down and annotating intents and slots and figuring things out. So anytime you want to combine two apps, you have to go and design it. How do you combine two apps together? Which means you have to design this ontology, you have to go get the data, then you have to train the model, then you have to ship the model. And the third-party ecosystems were really terrible. I would just say Alexa skills failed. I'm sorry, Alexa, any Amazon folks out here. And the reason was it was too cold. One was it was too onerous for people, either too onerous or too limited for people to be in that ecosystem. So what you could do is you can just you'll have an intent and then you sign up for that intent. And on the user side, it was too onerous for the users to choose what apps they want. Users don't want that to load to figure out what all the apps I want. The interfaces are also pretty basic interfaces. Either they're like CD kind, it's all natural language, really not rich output, and too expensively designed if you want to do that. Please don't look at this and try to read this. This is an example of the annotated stuff that we did to train these kind of assistants if you want to do composition of apps. My eyes hurt when I look at it now. But one of the reasons why it moves so slow. Now, ChatGPT came. So what can ChatGPT do? It's a superb language capabilities and change how humans and a machine interact and all in natural language. Amazing, amazing things. But it doesn't really do many things. And yes, plugins are there. We are trying to all use plugins and functions and so on. But they're clunky and it's almost going down the same route of having a few things and users have to choose them. And there's one classifier that selects which plugin is it going to and so on. It's a centralized architecture. So my question to all of you and all the smart developers out here is let's assume you all build really, really smart AI agents and all autonomous apps. For the user experience, what's next? How are users gonna use all of your apps? Are they going to go all to a different app to do each individual thing? How are they going to get advantage of combining any of these things that you all are doing without going through onerous code writing process and API stitching process and so on? For example, if you wrote, find a coffee shop between John's and my house that's open up to 4 p.m., it needs to call many different apps and so on. And yes, you can hard code this exact scenario and make it work, but it's not scalable. You're again going to the same problem that you have to hire 5,000 people to go do this stuff. What's the 3P story over here? How do we not become Google Assistant third-party story or Alexa third-party story? Any third party we can imagine in the assistant space, which was, as I mentioned, too hard to integrate, too hard for the users to decide. And here are my predictions, and maybe planting some seeds for brainstorming and discussion in all of you is, let's assume this ChatGPT is like invention of personal computer. Now a human and a machine are talking, so it's personal computer. What is the paradigm shift from a computer to an internet? How are these things gonna get interconnected and talk to each other? So first thing is, I think from a technical perspective, all of these agents are going to be more specialized, and maybe I shouldn't say this in the AGI house, but I do think that I'm a big believer in fine-tuning and making an agent really fine-tune on your data, make it really, really well, work on your task. Sometimes humans are specialized. We have some general intelligence, but we all know very different things. We are trained in different things. And I do believe the AI agents of the future would be specialized. So right now, we used to use prompt engineering to get unblocked, but I would say that if you could use how to fine-tune the models, that's even much better, because then you can make your app much more intelligent. It's going to be decentralized. In the future, all these apps and companies will have an AI agent. All of you are building AI agents. If there's one centralized place to do this, then again we'll run into the exact same problems. We'll have to figure out how do we make this a little bit more decentralized. Obviously, it cannot be fully decentralized. There has to be still some guardrails against adversarial modes and so on. But if we want to be successful in actually integrating this into an internet, it will need to be decentralized. The third thing is rich interfaces. Natural language is a great unifier. It's amazing. Humans have developed natural language over thousands of years. It's a really good way to communicate. But we also have screens now. And so can we make use of the screens much better? One of my learnings from being in the assistant area for a very long time is that it's very good. Natural language is good for certain things, especially if you're driving or something. But screens are even better for some other things. So if I have something on the screen, which I can generate, let's say UI I can generate with GenAI now, it's much easier for me to tap on it than to speak to it. So it's going to be the interfaces are going to be more multimodal, not just language-based assistant. But now you don't have to go and design every single interface. You can go use GenAI to generate these interfaces on the fly and improve them and so on. So here, that's it for me. Maybe hopefully that sparks some conversations around what's the future, where it is going. Thank you, and this is my email ID.
All right, last talk of the session, speaking of fine-tuning agents on your own data. So we have TJ talking about embed chains, which is in a project that's been going viral on GitHub in the last couple of weeks. Shortest path from your own data to building a ChatGPT bot. So take it away. Oh, that's fancy.
So hi everyone, I'm Taranjeet, you can call me TJ, and I don't have a PPT, I have a IPython notebook only. So I'm building Embed Chain. Embed Chain is a open source framework to build LLM powered bots. So we have a Python package and JavaScript package that we are catching up with JavaScript, but don't want to miss there. So let's do one thing, like we have a partyful page this. What we'll do is we'll create one bot over this partyful page right now. So what we'll do is we'll first import the environment variable. Basically we are setting OpenAI API key using this. And then this is the first line of code that you have to write, which is from embed chain import app. Now second is you create a bot, which is partyful bot equal to app. And now what you do is you just add a data set. So right now we are adding a data set of web page, which is this page. So what I've done is I've already stored it into my database. Now we'll ask some questions here. So like this is one question that we can ask. We can also ask another question like what are the rules? Oops, sometimes it doesn't work. So we'll demo you one more thing. So Elad was there. So we'll ask like who is Elad? And right now in the web page there is no context about who is Elad, right? So let's see. Okay, can we refine this? So what we'll do is we'll simply create we'll simply set an attribute called online. This means that now the bot will crawl Google search results. So now we'll do the Elad build query again. Yeah. So now it will get some context about Elad from Google and it will give this answer. So now bot creates, so what our framework, so what our pitch is, we are trying to be fast for creating LLM powered bots over your own data set or any data set. Behind the hoods, we are solving 3 problems. One is we are abstracting the entire process of chunking, embedding and storing in a vector database. Problem 2 is like we are figuring out the best retrieval strategy given a data type. And problem 3 is we are working on managing updates like the Levenstein distance and like diffing algorithm for embeddings. And this is our roadmap. Like we want to build out so we want to solve everything in and around embeddings. We want to build out an embeddings playground which is very similar to nat.dev. We want to also build out an open embedding standard which is like open API, which suggests that given a data type and a use case, this should be an ideal chunking, indexing and retrieving strategy. Third is embedding marketplace. Like we all are creating like chatbots over common data set. So why not there is a shared layer where you can simply download the embeddings like we have load dataset package from Hugging Face. And fourth is an agent which is a self-improving script which takes a data type and improves its answer accuracy. So if you're interested, you could simply visit embedchain.ai and start contributing. Thank you.
Okay, thank you, TJ. I would say let's give another round of applause for the speakers who came here. I'm sure you have enough inspiration to build products until the end of the year now through these talks. I'm gonna pass it over to Rocky with some logistics and PSAs. There you go.
Alright, so there's a Slack channel for those who are not on the Slack channel. Make sure you join that Slack channel because a lot of the announcements throughout the day will be there. Find there. And if you have any other questions, ping me there, Rocky. And for that, we have a project proposal session. So for those who are still looking for teammates, so you sign up on that. So first go to the Slack, there's an Excel sheet, and then sign up your project, your name, your pitch, and then come over here, do a quick, maybe less than 1 minute pitch, and then whoever would like to say recruit the right people to join your team. Before that, I have someone, sponsors here.
Thank you. Yeah, who want the credits to build the agents? Yeah. So in the beginning of the year, we had the credits from OpenAI, and we know that OpenAI functions is a backbone for agents. So what I'm doing is I'm implementing functions on open source. And for the hackathon, we have some credits for all of you to build agents using functions from gamma-api.com, gamma-api.com. So hopefully we'll have credits for the entire day because we know that agents consume a lot of that. And we want to kind of thank you so much for Motanon, our friends, we are working together, and Model, that's hosting the model. So it's really easy. You can go to your website, waitlist, you can log in, and as soon as you go to the Discord and post your email and project, we can approve your login on Gamma API. It's really easy. You get your API token here. We have an example. You just click example, go to the Colab, put your API key, and here we have some examples on how to build functions. The first example thank you to Harrison for launching this awesome example. Shows how to extract relevant information from a passage. And here you can see that the thing can extract the name, the sentiment, the aggressiveness, language, and other things. So hopefully you can build a lot of cool agents.
All right, thank you. And so again, we will have Josh who will help MC the project proposal session.
Thanks everyone so much for coming. I want to do something quickly before we get started here. By show of hands, who here is coming from Hillsborough area? Okay. Who's coming from the Bay Area? Okay. Who's coming from California, not the Bay Area? Okay. Who's coming from out of state? Who's coming from out of country? All right. Give yourselves a round of applause. So if this is anything like the last hackathon which we had, it's going to be incredibly fun. Definitely encourage you all to come at it with open minds, especially this phase when you start to hear project ideas. Be ready to experience some incredible ideas and share some awesome directions about where AI is going to go. And so with that, we are going to get started with Eduardo Rees. No, sorry. We'll get started with debate team. Someone from debate team, please. Debate team? Nope. Okay. All right, come on up. On deck, we're going to have tag next. So if everyone could, if you have an idea, please jump into Slack, jump to the Autonomous Apps channel, and then click the Google spreadsheet. You'll be able to put your ideas in and contribute if you want to jump in here and share.
Hey, got a couple of ideas. First one is debate team, which is a kind of society of bots idea where you have someone in a chat room will propose a topic, and some bots have to go and research the topic. Other bots take different sides of the argument, maybe navigate a knowledge base, and another bot will actually judge the results. So I'm DC San inside the Slack. That's one fun multi-bot idea. Actually, I put the next one down as well. Sorry, I had a couple of ideas. The other one's called Tag, which is a text adventure game. So using LLMs to generate text adventure game. Very simple, obviously, for hackathon, something like an escape room or a very simple puzzle. Then other bots are given a task to play that game and try and make their way out of it. So again, a kind of adversarial game bot environment. A couple of ideas. Thank you.
Love it. All right, awesome. Next up, we have Spellbound. Can someone from Spellbound jump in?
Yeah.
And then on deck, we're going to have agentic product development.
All right, so the quick pitch about Spellbound. Spellbound is a VS Code extension. You can actually install it. During this hackathon, I have a few ideas. If you're big into TypeScript, hit me up. Basically, it's a VS Code extension that can do anything on your code base. It can run your code. It can get real-time IDE feedback. It can do a lot of stuff. I want to build a plugin system for it. I want to explore type-driven AI development. So something like, say you're putting Haskell, and Haskell, you have a type signature, and then the AI can fill out its implementation according to that type signature, and you have more